Welcome to the Shikasa Boo Motor channel. This channel provides easy-to-understand explanations of car mechanisms. The first production car to adopt a DCT, dual-clutch transmission, was the fourth-generation Volkswagen Golf R32, released in 2003. Volkswagen refers to its dual-clutch transmission as DSG. At one time, it was praised as the ideal transmission, and many believe that all automatic transmissions would eventually be replaced by DCTs. However, due to the evolution of stepped automatic transmissions, and the inherent weaknesses of DCTs that couldn't be fully overcome, their adoption didn't spread as widely as expected. That said, in the future, their greatest weakness may be overcome through hybridization, and their adoption might become more widespread. This video explains the structure and operation of DCTs, along with the benefits of hybridization. This transmission is a special 6-speed DCT, designed by the Shikasa Boo Motor channel, specifically for explaining its structure. DCTs consist of a shifting section with a structure similar to that of a manual transmission, along with a pair of clutches. The clutches are hydraulically operated in most vehicles, with a few exceptions. To begin, we'll learn the hydraulic multiplate clutch and the shifting mechanism, which are key components for understanding how DCTs operate. The hydraulic multiplate clutch consists of an outer shell, an inner shaft, clutch plates and friction plates, and a hydraulic piston. The inner shaft and the friction plates are spline-fitted, allowing the friction plates to slide axially, while rotating together with the inner shaft. The outer shell and the clutch plates are spline-fitted, allowing the clutch plates to slide axially, while rotating together with the outer shell. The inner shaft is rotating. When hydraulic pressure is not applied, the rotation of the inner shaft is not transmitted, and the outer shell remains stationary. When hydraulic pressure is applied, the hydraulic piston pushes the clutch plates and friction plates against each other, allowing power to be transmitted. Next, we will learn about the shifting mechanism, using a simple 2-speed manual transmission. The gears are rigidly mounted on the input shaft, and they rotate together with the shaft as one unit. The gears on the output shaft are not fixed to the shaft. The shift sleeve is spline-fitted to the output shaft, allowing it to slide axially while rotating together with the shaft as a single unit. When the driver operates the shift lever, the shift fork moves the shift sleeve toward the first gear. When the teeth of the shift sleeve engage with the teeth of the first gear and the output shaft rotate as a single unit, transmitting power. This mechanism is called a dualclutch and is used in motorcycles and competition cars. When first gear is engaged, the second gear and the output shaft rotate at different speeds. To shift into second gear, the rotational speeds of the second gear and the output shaft must be synchronized. In motorcycles and competition cars, the rider or driver synchronizes this speed difference by operating the throttle and clutch. Manual transmissions and DCTs in production cars are equipped with synchronizer mechanisms that match the rotational speeds of the shaft and the gear. This video does not explain that in detail, but if you are interested, please watch this video. The link is in the description. Now, back to the 6-speed DCT. The engine power is transmitted to the input shaft. It is transmitted to the odd clutch and the odd input shaft, which control first, third, fifth, and reverse gears. It is also transmitted to the even clutch and the even input shaft, which controls second, fourth, and sixth gears. Gears on the odd input shaft are engaged with those on the odd main shaft. First and third gears, as well as fifth and reverse gears, each have their own shift fork and shift actuator. Gears on the even input shaft are engaged with those on the even main shaft. second and fourth gear, and sixth gear, each have their own shift fork and shift actuator. The output from the two main shafts is transmitted to the output shaft. The transmission is currently shifted into first gear, and the engine is running, but the transmission is not delivering any output because both clutches are disengaged. Engaging the odd clutch transmits power through the odd input shaft, the first gear, the odd main shaft, and then to the output shaft. While the vehicle is running in first gear, the system activates the actuator to engage the second gear with the even main shaft. Since the even clutch is disengaged, the even main shaft and even input shaft are not involved in power transmission. To shift into second gear, the system disengages the odd clutch while simultaneously engaging the even clutch. With no need to switch gears, the shift is completed instantly. This is the greatest advantage of DCTs. During the engagement and disengagement of the clutches, the system momentarily reduces engine speed to reduce shift shock. While the vehicle is running in second gear, the system activates the actuator to engage the third gear with the odd main shaft. Since the odd clutch is disengaged, the odd main shaft and odd input shaft are not involved in power transmission. When the even clutch is disengaged and the odd clutch is engaged at the same time, the transmission instantly shifts into third gear. While the vehicle is running in third gear, the system activates the actuator to engage the fourth gear with the even main shaft. In this way, during the upshift sequence, the next higher gear is always engaged with the main shaft, allowing shifts from first to sixth gear. Conversely, during the downshift sequence, the next lower gear is always engaged with the main shaft. While the vehicle is running in third gear, the system activates the actuator to engage the second gear with the even main shaft. By switching clutches, the transmission downshifts to second gear. And while the vehicle is running in second gear, the system engages the first gear with the odd main shaft. During clutch switching, the system momentarily increases engine speed to reduce shift shock. This DCT unit is quite large, because its components are laid out flat for the purpose of explaining its operation. In production DCTs, the two clutches and the input shafts are arranged coaxially to make the unit more compact. The odd input shaft is hollow. The even input shaft passes through the odd input shaft. The odd clutch is housed inside the even clutch. With this configuration, the odd shift unit and the even shift unit can be arranged alternately, allowing the transmission to be more compact. The greatest strength of DCTs, as explained so far, is the speed of their gear shifts. On the other hand, its biggest weakness is the jerking motion when starting off. At startup, the odd clutch connects the rotating engine to the stationary wheels. The conditions at startup vary, including the number of passengers, road gradient, and bumps on the road. Therefore, depending on the situation, the control unit's clutch control may not work smoothly, causing jerking. In hybrid vehicles capable of running on the electric motor alone, the engine disconnect clutch disengages the engine from the drivetrain when the vehicle is stopped. Since starting is performed by the electric motor, no clutch operation is required, allowing for smooth acceleration without any jerking. This overcomes the biggest weakness of the DCT. So, the adoption of hybridized DCTs might increase in the future. For more on hybridized DCTs, please watch these videos. There are links in the description. Thank you for watching. If you enjoyed this video, please consider subscribing to the channel. We'll see you in the next video.